For section 9.3, what we're going to look at is some more quadratic equations. We're going to look at solving quadratic equations using substitution. We're also going to look at solving quadratic equations with rationals in them. For our first problem, what we're going to look at is this. 1 over x plus 1 over x minus 1 equals 7/12. The first thing that you're going to want to do when solving a problem like this, just like when we were in Unit 7, is grab that domain. We have to be really careful that when we solve for x, if we get a number that's going to make the bottom of these 0, it can't be part of our answer. So for example, if you remember from Unit 7, you literally take each one of those denominators separately and set them equal to 0 and you see what you get. So basically x equals 0, okay, well there's one of our domains. I cannot get a 0 as my answer. If I get a 0 as my answer, it's going to make the bottom of this 0 and I can't have a 0 on the bottom. And then over here, of course, if you add that 1 over, we get x is 1, telling us again, I can't get a 1 as my answer either. Otherwise, it'll make the bottom of one of these 0. Now for 12 equals 0, that's just kind of null and void. We know that 12 doesn't equal 0. That's not even an equation. There's not even an x to solve for, so we can throw that out. So we want to check our domain first. We can't have a 0 and we can't have a 1. Now we go back into the problem, and the next thing we want to do is we want to find our LCD, because we're going to have to multiply by it to get rid of these fractions. And if we remember from Chapter 7, our LCD in this case is 12x, x minus 1. So you're literally going to go into this problem, and in the numerator, you're going to multiply each and every one of these by 12x, x minus 1, 12x, x minus 1, and 12x, x minus 1. So what's going to happen, for example here, is these x's are going to cancel, leaving you with 1 times 12x minus 1, or in this case, 12 times x minus 1. What's going to happen in your second fraction is this x minus 1 as a whole is going to cancel, leaving you 1 times 12x, or 12x. And what's going to happen right here is the 12s are going to cancel, leaving you 7 times x minus 1, or 7x times x minus 1. And you're going to be left with this. Now from here, we're going to go ahead and try to simplify this. So the first thing that I naturally want to do is distribute that 12 and that 7x in. Now the minute I do this, I notice I've got an x squared. And the minute we've got an x squared, we've got to go back to solving the way that we know how to solve quadratics, which is either by factoring, square root property, quadratic formula, or completing the square. So for all of those, let's set it equal to 0 and see what we have, basically. So I'm going to take 12x and 12x is 24x, and I'm going to minus that 24x over. And then I'm also going to add this 12 over. So what I end up with is 0 equals 7x squared minus 31x plus 12. Now I have got a ton of different options for solving this. I'm going to try to factor it. I don't know why, because I want to. I could do quadratic formula, I could do completing the square, really anything I want, but I'm going to do this. So in this case, I actually need two numbers that multiply to 84 and add to a negative 31. 84 coming from the 7 times the 12, which is negative 28x and negative 3x. And when I factor all of that out and pull it out, I get x minus 4, 7x minus 3. When I set both of those equal to 0 separately, I get x equals 4 and x equals 3/7. Now, since neither one of those are in my domain, both of those are my acceptable answers. Now I want to show you what it looks like when we solve using substitution. So I want you to look at this problem. Initially, this problem looks pretty nasty, and we could actually multiply all this stuff out, put it all together and solve it that way, which would be an extreme amount of work. So I want to show you a little bit of a shortcut called solving using substitution. So if you look at this problem, what it looks like I have is 2 times something squared plus 7 times something plus 5. In other words, it looks an awful lot like quadratic formula. I'm going to rewrite it, and instead of the word something, I'm going to put in a totally different variable, like a u. So 2 times something squared plus 7 times something plus 5 equals 0. Now, I know all of you would look at this and agree that that's a pretty easy problem. We could quickly factor that, solve it, and be done. However, this is not a pretty easy problem. But since the 4x minus 3 and the 4x minus 3 are the same quantity, why can't I replace them with a u? In other words, what I'm saying is, look, I'm going to replace them with a u and make this problem way easier to solve. So in other words, instead of solving this, I'm going to simplify it by substituting a much easier variable in here, and now I'm going to solve. Okay, so let's say we decide to do by factoring again. For whatever reason, I need two numbers that multiply to 10, add to a 7, 5 and 2, 2u plus 5, u plus 1. Keep going. Looks like I get u to be a negative 5/2, and I get u to be a negative 1. Now, I didn't ask you to solve for u. Although I am really grateful that you found this, I actually asked you to solve for x. So what you're going to do is, now that you've got your u's solving this much more simple problem, you're actually going to take your u's back up into this problem, this substitution formula that you wrote, and now you're going to solve for x. So let's first do it with the negative 1. So instead of u equals 4x minus 3, we know u is negative 1. So negative 1 equals 4x minus 3. Okay? Add your 3 over. Divide by your 4. It looks like one of my answers is x equals 1/2. Now I'm going to do it again, but now I'm going to do it with negative 5/2. I'm going to come up here again. Instead of u equals 4x minus 3, I know u is negative 5/2. So I have negative 5/2 equals 4x minus 3. So I'm going to add that 3 over, giving me negative 5/2 plus 3 over 1, get a common denominator of a 2. Negative 5/2 plus 6 over 2 is 1/2. So I've got 1/2 equals 4x. Divide by 4. Divide by 4, 1/2, divided by 4 over 1. You flip that second fraction, and your last but not least, you get 1/8 for x. So x actually equals positive 1/2 from up here, positive 1/8 from down here. In other words, we just used substitution at this point to create an easier problem.